Hey guys, we're going to do a quick video here about something called Pythagorean Theorem, and it's a large theorem in geometry. It's one that you should know really, really well because it's really applicable to a lot of things in life, to be honest. And so we're going to get into the basics of the video. I'd love to tell you the history of where it came from and all the fun stories, but I'm going to save that for different videos and class time and just kind of focus on what you need to know. So here's what you need to know. Pythagorean Theorem is all about triangles. And specifically, we're talking about these types of triangles, right triangles. Right triangles are the ones that have the 90-degree angle down in the corner. So that's the type of triangle I'm talking about. And there's kind of some important things you should know as you're taking your notes. When we look at a right triangle, and there's the three sides, the corner where the 90-degree angle is, well, what you want to know about that corner is that helps you identify where the two legs, that's what we call them, legs of the triangle are. The two sides or the two legs are right where the 90-degree angle meets. The side that is all the way across over here from the right angle is called the hypotenuse. That's how you pronounce that word, hypotenuse. So the hypotenuse is right across from the 90-degree angle. In fact, you can imagine taking that 90-degree angle and pointing an arrow over at the hypotenuse. And I know that all looks a little bit messy, but the idea is that you want to understand what the names of the three sides are. So if those are our three sides, let me show you something else here. This is not working very well. There we go. So what we like to do in geometry or in algebra is we like to label the sides A, B, and C, meaning that A, B, and C are variables. A is a certain length, like maybe the triangle is 5 inches long or tall, you could say. Or B is a certain length, and C is a certain length. And those lengths can be anything. It just depends on the size of the triangle. If it's a small triangle, there'll be, small numbers, and if it's a large triangle, it'll be larger. But the thing to note is that no matter what the lengths are, this always has to be true. This formula that I'm putting this messy box around must always be true. A squared plus B squared equals C squared. And this is a really big idea because this, you guys, is Pythagorean theorem. A squared plus B squared has to equal C squared. Meaning that taking A and squaring it and adding it to B and squaring it has to equal C squared to be a true triangle, which is kind of a cool idea. Let me show you where we're going with this next. So we all know how squares work. We know the area of a square is when you take the side and you square it. Well, if you take a triangle, a right triangle, and you build three sides off of it, this is really cool. I like this visual. So inside, here's the triangle, kind of shading it in there. If that's my triangle and I decide to build a square on the left leg over here and the bottom leg and off of the hypotenuse, I get these three different sized squares, which is great. One of them's built off the A side, so it measures A by A by A. One of them's built off the B side here, so it measures B by B by B. And one of them's built off the C side. Well, the reason I'm showing you this is because there's this really cool thing that happens. Believe it or not, those areas turn out to be something really kind of interesting. Watch this. If I cut the areas up and I start dragging the pieces over here, I'm going to move these pieces into the C squared box. So I'm going to move this over, find a spot to locate it. Let's see, maybe down the corner here. There we go. I'm going to put this one over here. I'm just going to drag these pieces around. Let's see, maybe there, and maybe up in that corner, and check it out. I can fit this here. Look at that. Isn't that cool? All the pieces from A and B fit into C. Hence, A squared plus B squared equals C squared. It's really kind of cool. And if I wanted to, I could show you with some numbers. Let me show you with some numbers here. Here's a triangle. Now we have some measurements. It's 3 long and 4 long on the legs. So then maybe that's 3 inches or 3 centimeters. I don't know the units. It's three square units in this picture. But knowing that, that means on the 4 side, the square is 1, 2, 3, 4 tall. And then of course 1, 2, 3, 4 across. So it's a 4 by 4. And if it's a 3 leg, then it's 1, 2, 3 across and 1, 2, 3 down. So it's a 3 by 3. So we know how to find those areas. We know that 4 squared is 16 and 3 squared is 9. So the area of this big blue square is 16 units, and the area of this big green square is 9 units. Well, check this out. I'm going to move all those squares quickly over to the big C. I'm just going to start filling up that box. I'm going to fly over there. Isn't that cool? So all the C's fit inside of here. Perfect fit. A squared plus B squared equals C squared. And it turns into this square that measures 5 by 5, which is really pretty cool, I think. Another way to show this is with the formula, which I'm going to write on the left side here. So we know A squared plus B squared equals C squared. In our problem, in this example, A is right here, you guys. It's 3. So what I'm going to do is I'm going to write equals A, nice and small there. And B is right here, you guys. It's 4. So I'm going to write equals B, or I'll just put a B up above it. So in this equation, here's A, here's B. We're going to replace them. We're going to use 3 and 4. We're going to do 3 squared plus 4 squared equals C squared. And we already know what 3 squared and 4 squared is. I mean, we have the math here. 3 squared is 9, and 4 squared is 16. So 9 plus 16 has to equal C squared. And 9 plus 16 is 25. You add that together, that's 25 equals C squared. But if I was just trying to figure out how long is C, I would have to square root both sides. I would have to take the square root of 25 and the square root of C squared just to get a C, to undo that square root. So C is going to equal 5. All right, well that's exactly what we got here. C is equal to 5. 5 by 5 makes 25 squares. And that is Pythagorean theorem. And to be honest, as you're kind of looking at this piece right here, I'm going to put a big box around it here. That's how we're going to be using Pythagorean theorem. We're going to be taking two values of a triangle and plugging them in, substituting them in to solve for the missing side. Okay, so here's a triangle, you guys. We know two side lengths. We know that it is 5 and 12. This leg measures 5 units long, and this leg measures 12 units long. What we don't know is this leg, the hypotenuse. We do not know how long x is, that length. So we're going to solve for that length. That's the next step in our problem here. So here's how I'm going to set that up. I'm going to use the formula. A squared plus B squared equals C squared. Or in this case, C squared equals A squared plus B squared, however you want to write it. And if A is 5 and B is 12, I have 5 squared plus 12 squared equals C squared. Perfect. Okay, so let's do the math here. 5 squared is 25. 12 times 12 is 144. If I add that together, that's 169. So I have 169 equals C squared. Well, I got to get rid of that C squared by square rooting it. So I'm going to square root both sides. And the square root of 169 is 13. So we now know, based on the formula, that this length is 13 units long. Maybe inches, maybe centimeters, maybe yards, I don't know, but it's 13 units. And that's my answer. All right, so let's try another one here. All right, let's try this one. Let's say we know the length of this triangle is a 6 by 10 by something. Now you're going to pay very close attention to the fact that we know A is 6, but we do not know B. What we do know is C is equal to 10. So this time they gave us A and they gave us C and they did not give us B. So now we have to solve for this a little bit differently. Check out how we're going to do this. We're going to set up our formula. A squared plus B squared equals C squared. This time I'm going to rearrange by saying, okay, I need to solve for the B this time. So I'm going to take A and subtract it over to the other side. Move it to the other side. B squared equals C squared minus A squared. And then I'm going to take 6 and 10 and I'm going to plug them in. I'm going to substitute them in. 10 is C, 6 is A. 10 squared minus 6 squared is 100 minus 36. So that'd be 64. So b squared equals 64. Okay, let's take the square root of both sides. The square root of 64 is 8. b is equal to 8. There's my answer. b equals 8. So I know I'm kind of showing my work a little bit messy in this video, but I'm trying to show you the idea that whenever you have this right triangle with a 90-degree angle in the corner, you can use this Pythagorean theorem to solve for one of the missing sides. A squared plus b squared equals c squared. And it's really kind of cool how it works. So I'm going to be posting a bunch more videos on this, but this is kind of our startup video to just understand how the formula works. And truly, I want to make sure you guys get this down in class. So hopefully this video helps, and I'll post some more. Thanks, guys.